Based on our experience, about 50-80% of total build time is typically wasted doing redundant work. This is potential CI/CD infrastructure distress that is there for us to catch, right? Brian just covered the three main offenders when it comes to ephemeral CI doing redundant work. So he mentioned the loading dependencies, then the build environment setup, and the all unnecessary rebuilding that can go on and on. Using this specific example, over 7 minutes are lost for each CI build.
Okay, so what do we do, right? How do we stop this waste? What happens when something is slow in computing? What do we do? The answer is almost always the same, right? You cache it.
Okay, good day everyone, and welcome to this great old webinar. I'm your host, Oliver White, and joining us today for CI Without the Wait, Scale Throughput with Develocity Universal Cache are my two fantastic colleagues, Brian Demers and Mirko Dada. If you've been working with CI for some time, you're probably used to the typical developer productivity challenges that come with it, wasting time and patience with ephemeral builds starting from scratch, difficulty troubleshooting failures, and so on. And if you're an organization that has adopted AI coding assistants to any significant degree, you may have noticed things getting even worse lately. Recent surveys report that in the last 6 months alone, lines of code per developer have increased by at least 75%, and the size of pull requests has increased by 33%. As Amazon engineer Joe Magaramov, apologies if I butchered that last name, pointed out in his recent blog post, which was featured in our last DPE newsletter, when his team began to ship commits at 10x their previous rate, he lamented that, quote, "The overall math changes, and what used to be a production-impacting bug once or twice a year can become a weekly occurrence," end quote. And this is why Brian and Mirko are joining us today. In order to keep up with the normal code base growth now magnified by a fire hose of increasing batch sizes and more frequent commits, we need better caching and more of it. In fact, we need what we're calling a build artifact CDN, represented by our newest addition to Develocity, Universal Cache. Finally, this webinar is brought to you by our hundreds of happy customers, including Calibra. Calibra is Belgium's first technology unicorn. They're now worth over $5 billion, and they provide a unified data governance and AI platform to over 700 customers worldwide. They use Develocity's remote build cache on CI, which we will hear about today, to reduce their build times by over 60%, and last year they saw an impressive 40% reduction in test cycle times by using Develocity Predictive Test Selection. I mention them because they have various engineerings available in New York, North Carolina, Prague, Czech Republic, Poland, and Belgium. So visit Calibra.com to find out more. Okay, that's all from me. Let's hand it over to Mirko and Brian. Welcome, guys. Thanks for joining us today.
Hey, thanks for having us, Oliver. All right, so Oliver already introduced us, but I'm Brian Demers, and with me is Mirko. And I think Mirko is going to get us started here.
Yes. All right. Thank you, everybody, for joining. Let's start today's webinar by looking at a screenshot from Develocity Analytics, showing a week of CI network activity from a real-world organization. The loading dependencies is a common source of time and resource waste on CI, as we all know. In fact, can you confidently answer whether dependencies downloads on CI isn't a bottleneck in your organization? For the organization we have on screen, this is very easy to assess. Let's look at the data together. So the total dependency download size over a week is 7 terabytes. Do you know what is the volume dependencies, the volume of dependencies downloaded by your CI system in any given week? If you do, let us know in the chat. We're very curious about it. Downloading these dependencies sums up to almost 20 days of download time. This is weekly load the artifact repository and CI underlying infrastructure must handle. The overall wall clock dependency download time is more than 5 days during just 1 week, over just a 1 week window. That's a sizable waste of time and money for the whole organization. Thanks to observability, it's easy to assess the magnitude and the opportunity cost of the problem across an organization. But how do we go about fixing it? We'll get there, don't worry. But before that, let's cover some more challenges that platform engineering teams all around the world face on their day-to-day with the CI/CD infrastructure.
All right, so let's talk about build volume growth, right? So this problem is only getting worse, right? So your code bases are growing, and that puts more pressure on your CI system. Like that's just a fact, right? If there's anyone here that is deleting more code every year than they're adding, let us know. I really want to know. Every once in a while, I'll give a talk and I'll make this statement, and there's one person like in the back of the room waving their hand with a ear to ear grin. That's the one person that I know that is deleting more code. But most of us, especially if you work at a large organization, you're adding hundreds of thousands, if not millions, of lines of code to your code bases every year, right? And it doesn't even matter what it is, right? You could be adding bug fixes or adding new features. Hopefully it's not a million lines of bug fixes, but I'm not going to judge, right? But we're creating new projects. Some of those have new repositories. Sometimes it's in a monorepo. None of that really matters. All of that is just load on your system, right? And it's growing year over year. So if you look at a snapshot today and you look back historically about, how long your CI builds are, what your commit volume is, the size of your code bases, all of those things are growing, right? So a growing code base typically means a longer build, right? And the more developers, the more commits you do, there's more load on your CI system. Both of those are playing at the same time. So a longer build, maybe you're adding more tests every year, so that your test cycles are growing. It doesn't matter what it is. The load on the CI system is increasing. Now, then we add AI and cogen and all this other stuff into the mix, and that problem just got worse, right? Some companies are seeing a 5x growth in commit volume. Oliver just gave an example about 10x. So the question is, right now that we can code faster, can we deliver it faster? Often the answer is no, right? There's a bottleneck. And if you can code faster and deliver faster, does that mean your CI system is going to incur a 5x cost increase, right? It's probably, when somebody gets that bill, they're not going to be impressed about it. So really the traditional CI CD infrastructure is built kind of around the assumption that humans write code at human speed. Each developer on your team, they're committing a few times a day. They're pushing changes, and that's everybody. But that's still a fairly limited number of changes. Each time a build runs, we're going to start from scratch and download dependencies, initialize tool chains, right? Recompute outputs that have happened already dozens of times throughout the day. However, with the growing AI adoption, with all the AI assisted development tools, this assumption is kind of obsolete. Many of us have moved to ephemeral builds over the last few years, especially now. I don't know how many companies I've talked to that are still trying to get there, but that's sort of the norm now. It provides a lot of great security benefits for doing this and a lot of stability. However, each build starts with a clean slate, right? So if you're not familiar with ephemeral builds, it's basically a build that starts clean every time, right? So you can think of GitHub Actions as the de facto model for this now. But each build starts, it's going to download all your dependencies, right? It's your build tool needs to do some initialization. So in the case of Gradle build tool, you can think of that compiling all your build scripts or calculating the task graph or those types of things. But most of the changes we make are actually really small, right? I'm going to, if I'm working on a code base that's 100,000 lines, I'm going to change 2 of those files or a handful of those files, right? But it doesn't matter if I'm making a really small change or really big refactoring, my full build is going to run. And that's a lot of wasted resources here, right? So if your company is using a repository manager that's in the cloud, that's a lot of egress costs, right? Network bandwidth back and forth. If it's not in the cloud, right, it's still a lot of strain on that system. So you're managing your system. Maybe you need to scale up the number of nodes your repository manager has. There's probably some licensing costs involved there. So increased build volume, increased traffic, increases the cost that you bear. And we're rebuilding and retesting that code that hasn't changed, right? So there's a ton of waste there. If you're building in cloud agents, every one of those minutes is costing you money, right? And time, right? Time is this thing that I think gets swept under the rug a lot, but slower feedback times, if my build takes 2 minutes versus my build takes an hour, what am I going to do here, right? The 2-minute build is much better. I'm going to get faster feedback. I'm going to be able to do more throughout my day. But really, I'm waiting for that feedback from my CI system to give me a green checkbox so I can hit the merge button, right? All of those things are costing us money.
So in large enterprise systems, this duplication of work is substantial. Based on our experience, about 50-80% of total build time is typically wasted doing redundant work. This is potential CI/CD infrastructure distress that is there for us to catch, right? Brian just covered the three main offenders when it comes to ephemeral CI doing redundant work. So he mentioned the loading dependencies, then the build environment setup, and the all unnecessary rebuilding that can go on and on. Let's make this concrete by looking at a few real-world examples. So first, here we have a look at the cost of the loading dependencies. On screen, we see a Develocity build scan published by a CI build from the Apollo GraphQL project, and it shows how significant dependency download can be. Over 2,000 dependencies are downloaded, totaling for about a gigabyte of data. This results in 4 minutes and 38 seconds of pure wall clock time spent on downloading alone. That's a large bottleneck for a single build. As a second example, let's have a look at the cost of setting up the build environment for a Gradle build. If you're familiar with the Gradle build tool, you know that before executing, a build needs to evaluate what work needs to be done. This is about computing the task graph. On an ephemeral CI build, this work is repeated again and again. Using this specific example, over 7 minutes are lost for each CI build every single time. And third, let's look at the cost of redoing unnecessary work. Here, we're looking at a Maven build from the Apache Streams Pipes project that was more than 8 minutes long. No matter the change, it could be as little as fixing a typo in a comment or as big as a large code refactoring that really span all over and throughout the code base. 8 minutes is the time that it will take to execute the specific build. In short, oftentimes we end up rerunning goals or tasks whose inputs have not changed. So, spoiler alert, for this specific build, we see that over 6 minutes of work could have been avoided if the Develocity build cache was used. And we're gonna definitely see how later on.
Okay, so what do we do, right? How do we stop this waste, right? And if you ask what happens when something is slow in computing, what do we do? The answer is almost always the same, right? We cache it. So caching is the solution here. And of course, the most important thing, the cache needs to be close to where it's being used. Because if it's far away, you're still going to hit all of that network latency and you're not going to see the same benefit. So if we think about this, though, a cache that's close to where it's being used, it's a lot like the modern CDN. Right. So I live an hour or two north of Boston. I know Akamai has a node in Boston. So maybe some of the services I'm using, I'm going through that. Maybe I'm hitting, Amazon's, I don't know, Virginia, depending on what service I'm using. I benefit from a lot of regional proximity to these things, which reduces the latency and speeds up my downloads. Now, we can apply the same thing to a build, right? So with a build artifact CDN, we're going to take a very similar concept. Each node in the build artifact CDN has all the content my build needs to accelerate it, right? It's located on the same network as my CI system or the CI agents. And you can even have nodes that are close to your developers so they can get the same benefits. But for this talk today, we're mostly focusing on the CI use cases, but you can imagine the same benefits from folks. So if your CI system is in one spot and your developers in a different country, you can have a node close to them and everybody benefits this way. There's a little bit of a difference between a traditional CDN and the build artifact CDN. So in a traditional web CDN, like if I publish my static website, I'm going to publish it to a single place, and they're going to manage the distribution to get to all of the various nodes, right? The point of presence nodes. But the build artifact CDN, the CI system is going to push to the node that's closest to them, and then the node will then handle distributing the data elsewhere. So at least the uploads are still very fast, and then all of the scaling out of that data still happens behind the scenes without your interaction. It's close to your CI system. The replication can happen in the same region and across regions. All right, so we touched on a little of this before, but there's basically three big components to the universal cache, right? So universal cache is a build artifact CDN. So setup cache, as Mirko mentioned, really, this is going to start your build tool faster, right? So if you think about how your build tool works, it's going to start up, and the first thing it's going to do is process things, configure out the configuration it needs, compile, build scripts, whatever all of that configuration is, that has to happen before it does any work. So setup cache helps with that. We're going to download the bits from the previous build, and that'll accelerate the startup of your build tool. And then, of course, artifact cache. We've talked a lot about how this can speed up dependencies, but a lot of builds spend a lot of time downloading dependencies. So instead of downloading them one at a time throughout the build, we're going to download them all at once. And you can get probably 95% plus improvement here. So we're going to download all of your dependencies at once. And then, of course, if something changes, you're going to download the change dependency as your build normally would without any changes. So if you're using an Artifactory or Nexus and you get a dependabot change, of course, that's not going to be in the cache. So that artifact will still come from the source you're using today. And next up, we have build cache. So while your build runs, there's a lot of work that happens and it's the same every single build. So if I want to think about this in a really simplistic form, you could think about a hello world Java class, right? If I use the same, source file, system out, print line, hello world, right? In a little main method, and I run that through Java C, I'm going to get the same output, as long as I have the same inputs. So as long as I'm using the same JVM, the same arguments, right, the same class path, I'm going to get the same output. So I could take that output and then reuse it next time I want to do compilation. Now, of course, compiling one class file is trivial, but if I have a million lines of code or I'm testing, my tests take forever to run and they haven't changed, the inputs to the test haven't changed, I can get significant benefits from downloading a previously cached version of that, and then skipping that compute, right? So I'm trading a little bit of network for trading a little bit of compute for a little bit of network, and of course, like we mentioned, the network is the node you're downloading from is on the same network, so it's very fast. And of course, all of this needs to happen in a unified system, right? Single backend and one layer of access control for your platform engineering teams to manage, unified observability across the whole system. All of this needs to happen to get these benefits.
All right, thank you, Brian. Let's see then what happens when universal cache is used with the three problematic builds we've seen before, starting with the loading dependencies. So at the top, we have the same build scan we've seen before for the Apollo GraphQL project with 4 minutes, 38 seconds of pure wall clock time spent on the loading dependencies. And at the bottom, we see the benefits of using artifact cache. No dependencies needed to be downloaded during the build execution. Second, let's review the build scan showcasing the cost of setting up the build environment for a Gradle build. On the left, we see the configuration time accounts for over 7 minutes. On the right, With setup cache, we see that the configuration time is drastically reduced. And third, looking again at the Maven build from the Apache Stream Pipes project, we see that the potential 6 minutes saving from the build on the left can be essentially realized thanks to the Develocity build cache, as you can see in the build scan on the right. The overall execution time decreased from over 8 minutes to just under 3 minutes. And now you may be wondering how it all works under the hood. So let's take a closer look at universal cache and what happens really under the hood. So here is what happens on an ephemeral CI build when you're using universal cache. Before the build starts, artifacts are downloaded. So dependencies, Gradle Maven wrappers, build environment setup, and more. Next, the build runs as it normally would. And if there is any new dependencies that is being introduced, imagine that you're creating a PR and in that PR you're bumping a dependency, while that dependency cannot be yet in the universal cache. So it will be downloaded just by the build, just like it would normally do, right? Then all the build cache entries are also downloaded from the same edge node. This is what is going to prevent that computation that has already happened is redone again. This is how you can get all this execution saving that we have seen realized just in the build scan before from the Apache Pipestream project. And at the end of the build execution, a build scan is published. By using Develocity, this is always what happens. Then when that's done, the cache is updated with anything that is new. So if we take in the running example, when we actually did have a new dependency, well, that new dependency will be pushed to the cache, right? So that the next PR that is going to require that dependency, well, it will be already pre-configured, right? The CI job will already be provisioned with that additional dependency so that it doesn't have to be downloaded again. And of course, the system uses the intelligence from the build scan to keep the universal cache lean and optimized.
Awesome. All right. So let's talk a little bit about observability for a second, right? So anytime I talk about observability from a build tool perspective, it's there's not a lot of people doing it, I would say, which is mind-boggling to me, because you wouldn't put an application in production, right, without some sort of monitoring. Right. Everyone would hopefully raise their hand. I know some of us have done that before, but we don't like to admit it, and we know it was wrong. Right. But when you think about your build tool, they're often running older versions, or there's no observability in place. It's a problem, right? Now, if you have 1,000 developers at your company, and something in your build tool or your pipeline, or whether it's your CI system or an issue with your build or whatever it is, if there's a problem there, it's going to affect all of your developers, right? So there's an outage, right? Think about every time you've seen the angry unicorn on GitHub, your whole team is sort of feeling like they haven't, they can't do what they're supposed to do. But that's like worst case, right? Things are broken. Those are pretty clear. The system is down. I know it's down because everything fails, right? But really what we see often is things aren't broken. They're just not optimized. So, your build is slower. So this is really, if you think about it, kind of a maturity level of your build system. Do you have these things in place? If you don't, you really need to think about adding some observability to your build tools, right? Again, is the process slowing down, right? Is your build getting slower over time? Probably, if you're not doing anything, right? How do you prove how much slower it's getting over time? When did your tests become flaky? Right? I love to talk about flaky tests. Right? Some people don't even know they have flaky tests, and I will, as long as you have tests, right, which hopefully you do, I guarantee you have some level of flakiness in your test, and you need to be able to track that. If you think about provenance, right, from where a dependency or an artifact came into the system or where it was produced, how do you get that information without some sort of observability, right? You need it to answer all kinds of questions. If your build is failing, again, right, you need to have that data to go troubleshoot it. If it's running slow, you need that data to make it faster. You need to optimize your build. You need to figure out what is slowing you down. right? The first thing you do if you're doing any performance tuning of any application is you measure it. You figure out where the problems are, and then you go fix it. So we need to take the same approach to our build tools. Everything Mirko showed today is possible because of observability data, right? We couldn't do any of that without capturing that data. So because of this, we're able to pinpoint problems in our build, and as Mirko showed, we're able to fix them too. All right, so I asked the question a few minutes ago, right? So you can write code faster now, right? Hopefully everyone's using AI to its maximum benefit. Or maybe you're just a better developer than you were, so you're writing code faster. Can you deliver it faster? Right? Hopefully you can answer that question now. Yes, and of course, I want you to answer that question yes without increasing your CI spend, right? If nothing else, if you take nothing else away from this talk, you need to have observability to figure out what your issues are. Without it, you can't find the problems, and of course, you can't fix them. You can't prove to your boss that you fixed them. Okay. Whether you're using AI and AI code gen or not, depending on how you feel about it, it's irrelevant. Our code bases are growing. Gen AI is obviously making that problem worse. So we need something to manage the increased cost of CI, and caching is one way to do that. And of course, the 3 layers of caching we talked about: artifact cache, we're going to reduce the network bandwidth. Setup cache is where we're going to make the build tool start doing work faster, start up faster. And then build cache, we're going to reuse parts of previous builds to reduce CPU usage and speed up our builds. And of course, all of these caches need to be in a system, a unified system where you can manage access control and get the observability you need. And Develocity Universal Cache can help with all of these. All right, with that, I think Oliver's going to jump back in. And then we're going to get to questions.
All right. Just the guy everyone's waiting to hear from. This is a quick slide for those on the call that are already Develocity subscribers. This is a QR code that will let you notify the folks on our team to let you kind of get access and figure out how to implement this on your side using Develocity Edge and so on. So if you're already a Develocity subscriber, you can get in touch with us quickly here. And then there's one more slide after this.
I've got it.
And these are for the folks that are not yet Develocity subscribers and are interested in learning more about what we do and how it helps you with developer productivity and handling the fire hose of CI. We have a guided trial. Scan this. We go through a guided process with one of our engineers. It's a very pleasant process from what I hear from our customers. And at the end, you get to present a final report with a full ROI of what can happen if you're using some of these features versus not doing that at all.